Okay, so let's start with today's daily challenge, that is decode base. So in this question, we are given a string and we have to map it into message, and the decoding is done as A will be mapped to 1, B will be mapped to 2. Similarly, like in this, 1 will be mapped to A, 11 will be mapped to K, something like that. Okay, so the this will be our mapping, that A will be mapping to 1, B will be mapping to 2, and similarly Z will be mapping to 26. So I hope the question is clear, because let's first see here. So in 11106, either we can choose 1 as A, or we can choose 11 as K. We cannot choose 111. Why? Because it is greater than 26, and we only have to map the letters, that is A to Z. We cannot do that. And one thing to note is that the grouping 11106 is invalid. We cannot do that because 06 cannot be mapped into F. And here 6 and 06 are two different things. So we cannot do that. This term is invalid in this question. So we don't have to do that. So whenever we are seeing 0, so we cannot take 0 as the first index. We have to keep that in mind. So I hope the question is clear. What we actually need to do, let us make it more clear using some of the examples as it is shown here. So here the S is 1, 2. So how many ways can there be? Either we can take this as A, 1 as A, or we can take 12 as a, right? Similarly in this question, the first way is to take 2. 2 is B. Then we can take 22. 22 is what? 22 will be V. 22 will be V. So either we can write S. Let's just see this. It is 226, right? So if we make a recursion map of this, so it can be either we can take 2 or we can take 22. Hmm? So if we took 2, so the next for next indexes, either I can take 2 or I can take 26. Either I can take 2 or I can take 26. Now with 2 for further, I can take only 6, right? So and with 22, the one more way can be there, that is 6. So how many total ways are there? One is this, another one is this, and the next one is this. Hmm? So there are total 3 outputs. Similarly, 06. How can we give 06? As 06 is an invalid one, we will give it as a 0. Right? So how to let's first see that what are the important things that we need to keep in mind. So the things we need to keep in mind, let's write it, that we have we have to keep in mind the current index. Look, current index as well as the index plus 1. We have to keep it. We have to look for 2 as well as 22. Hmm? And the second thing is that we cannot take 0 as our first element. Okay. So whenever index, like this is string S, right? So if S of index is equal to 0, then what we have to return? We have to simply return 0. if the first index is 0, then we have no like in this question. Let's see this one. So here 1 1 1 10 6. So here 0 is taken consideration when it is not the first not the first element. Yeah, right. And whenever it is the first one, let's see here, it will be an invalid one. So we have to return 0 there. Is that clear? And now one more thing that we have to keep in mind is this the range of it. Hmm. That number we are we are working on should be less than or equal to 26. So if we are seeing this, so what can be our first element? We are saying that our first index cannot be 0 and our number should be always less than 26. So the first element can be what are the possible first letters? So the possible first letters can be either 1 or 2, and that also if 1 is there, so second digit, or if first is 1, then second letter can be anything, right? But when the letter is 2, then the second number should be either 1 to 20, 1 to 6, something between 1 to 6. When the first letter is 1, then the second letter can be anything between 1 to 9, 0 to 9 actually. Can be anything between 0 to 9. And if the first letter, let's rewrite it clearly, that if first letter equal to 1, then second letter can be anything. And if first letter equal to 2, then the second letter should be between 1 to 6. This is clear. And we have to, like, if 2 is there, so if 2 is there, let's firstly move some of the things here. So this was our tree. So see, if we are taking this one, so we are seeing that if this is the if we are taking 2 as first point, so there are two number of ways, this and this, and we are taking 22, there are one one way. So the total way, that is 1 plus 2, that is 3. So I hope you understand. Firstly, we will take answer from one digit. Then we'll take it from two digit, and then we will sum it up. So let's start coding. So let's make a function for it. So as it is returning int, so we have to take it as int and function. And we have to keep our eye on our index, and we have to take our string with us. String with us. Fine. So what we have to calculate. So we have to calculate in, let's say, if we are taking first letter, then what we need to calculate, that whatever it will give after, whatever the letter after that will give will be, if we are selecting one digit, if we are selecting two, then whatever the next one will return That will be our answer. So it will be equal to function of index plus 1. And the next thing is if second. So what will second give? So second will definitely give when we are encountering the I plus digit. I hope that I am clear to you. If not, then let's see. So if it is I, right, it is I. So we have to see whatever the next one is. So this is what it is representing. That the answer will be depending on this. But if you are taking 22 as an individual, so what in what it will be depending? It will be depending on this, right? That's why if this is an I, so if one is if only first letter is taken into consideration, then we will check the next one. And if two are we are taking two digit into the consideration, then we'll take I plus 2th element and we'll give the answer according to that. Right. So okay, but what if I plus 2 is not in our range? It is less than the size of it. So firstly, let's initialize it with 0 and we will check that if our I I plus 1 is less than equal to s dot size. And one more thing is this is a compulsory one. And one thing is that our first letter can be either 1 or 2. Hmm. So first letter is 1 or 2. So we have to check that if s of I is equal to 1 or if it is less than our size or it is the first one is either s of I equal 2. But when it is 2, we have to keep in mind that element, the next element should be between 0 to 1 to 6. So we have to keep in mind that s of I plus 1 is greater equal to 1 and s I plus 1 is less than equal to 6. If this is the case, then I will say that my second is equal to 1 of index plus 2. Let's let's make it I instead of index because we have written all this into I only. So okay. So if second is so we will keep second as this. Now the final answer will be what? Our final answer will be we have to return first plus second, right? First plus second. And the break condition. This is the recursive one, but the base condition that we need to follow is see. When first will be that if we are on the last we are on the index, so we will simply return one. That if we reach the last one, so this is one way. And the second one is we have to consider this 0. So if uh, s of I equal to 0, then we have to simply return 0. That there will be, we won't be going further. We will simply return 0. And one thing can be I think this much is fine. So now let's call our function. So return function of 0, comma s. Let's run it. Okay, so s should be passed here as well. Now let's see. Having a problem at this example. I think everything looks fine. One thing that we have to make it string of 6. Really sorry for that typo. Now this will run fine. Yeah, it is. So this solution is good when we are. Let's first clear our screen. So this works fine for the base cases, but see the constraint here is 100, and for every index we are having two. Uh, we have two options to select. So it will be 2 to the power 100. So it will definitely be failure if we submit it. So we have to optimize it. So how can we optimize it? So how to optimize it? One thing is that the only thing that is uh, deviating is I. So let's make a of dp of size, let's say 100. So it will be 101, and we will set our dp. So we have to set dp with -1, the size of dp. We have initialized our dp. Now we have to check that if we are at some index, we need not to recompute it every time. So if dp of I is not equal to -1, then we have to simply return dp of I. And wherever we are returning this, we have to say that dp of I is equals to first plus second. I think now it should run fine for big cases as well. So for s is equals to 1, for s is equals to 1, the outputs are so here first we'll give answer as 1, and second is initially 2, and if I plus 1 is less than equal to, I think it should be this. Let's run and let's copy this, fourth one. Now let's run it. For 4 it should be 1, and it is giving 1. Now it is fine. You can take 1. we will have 1, 20, 1, 2, 3, 4, 1, 23, 4, and 1, 20, 12, 34. Okay, this should not be compulsory. It can be 0 as well now. So we have to replace it with 0. Now let's submit it. So this is our answer. That's all for today. Thank you.